just talk something about my study, my research. One is for the nanomaterial, yeah, for example, graphene or metal oxide or more. The other application is biosensing application. We also, for the energy storage, or for example, supercapacitor application, or solar cell, or another type. We also use all the nanomaterial for the photocatalytic application. Okay, but so many teams is a focus of my study. For example, the synthesis. For example, the 2D material. For example, graphene or sensing application for biomedicine or environment. Or we also so many principles. For example, electrocatalysis, bioelectrocatalysis, or applications so many fields for biosensor, or in vivo in vitro detection, real-time detection, or simultaneous sensing. Yeah. So I will just from the material, also from the methodology, also use so many chemical method technique. One is a material. We use so many different type material. For example, metal oxide, nano metal particle, or graphene, or carbon material, or any more. The second, we use so many technique, different type technique, especially it is chemical method. We also use different type function by the different type methodology. But so many target, we have determination. For example, important neurotransmitter, melatonin, or health glucose detection. Yeah. But not just this one. We also use so many types for the energy. For example, the solar cell, the dye-sensitive solar cell, or so many interference phenomena for the electrochemical procedure. I will just give an example. But the technique, for example, we like the current response. For example, cyclic polarimetry, or DPV, or amperometry, or more. But all methodology we use. But the material is very important for the chemical sensor and biosensor. The technique, for example, polarimetry, but the film is very important for the nanomaterial. Different type, protein film or animal film. So many type polarimetry is perfect, but we have a focus and we have a very detailed study for the mechanism, for all the reaction mechanism, including the chemical procedure, chemical procedure or more. Also, so many nanomaterial we also use. For example, the molybdate or silicon molybdate, or molybdate with some transition metal compound or more. But it's beautiful. We get so many ideas from nature. You can find so many polarimetry similar the nature beautiful field. Yeah, it's also same. Yeah, so many peaks where relative to the its chemical mechanism or chemical mechanism. But so many methods we have used. For example, control potential or potential state or potential sweep or constant potential. Also, so many different type electrode we use. 2 electrode, 3 electrode, or flow flow system, or multi electrode system we also use. Yeah. But anyway, all the electrochemical method or the detection is low cost or cheap or time saved. But real-time detection is very important. Also, high sensitivity also important. Portable also important. But all this is also related to the short time response. We have so many carbon material we use, from the filtering, CNT, or graphene, or diamond, or more, or graphite sheet. So many different carbon we use. We also combine these are the support material for electrode. For example, diamond, zero dimension carbon 16, or CNT, or 2D dimension graphene, or more, or as a supporting material also favor the conductivity for the electrode surface. This graphite, we use some different method transport to graphene oxide, and then graphene oxide we will transport to reduce of reduce graphite oxide or transport to another type. Yeah, also composite we allow. But the important procedure is from graphite to graphite oxide, and then by reducing aging, or important is chemical method to it is ERGO, or also another type, for example TRGO or CRGO. But the ERGO is very special for our case. And there are so many another type. Binary transition metal oxide, selenium or sulfide were also used. For example, metal oxide is a different type of synthesis. Microwave method, hydrothermal method, tempered method, or its chemical deposition, or we are used for the synthesis. But also some 2D material were also used. For example, biomimic compound, porphyrin, is very famous in hemoglobin or myoglobin. Yeah. We also combine with some enzyme, for example, glucose oxidase with graphene or graphite oxide also used for this field. But the other type, 2D material, were also used. The big famous, yeah, the graphene is one. 2D selenium or sulfide or TE is also same, or 2D oxide also used. Yeah. So many 2D material, not just graphene or selenium or sulfide or the other type 2D material were used. I will give example later. Yeah, this also famous method 2D material. This, but not just molybdate, magnesium, iron, cobalt, nickel, or any more 2D material or famous material were also used for our application. But not just 2D material. Some perovskite structure material also used. We have just give some example perovskite type, nickel oxide type for the long enzyme glucose biosensor. This just give one example. The second example, we also use calcium stannate also for application for the some detection or some sensing application for mental. Yeah. So we also detection used for the anti-cancer or the other drug application for the detection. Use ternary or binary or ternary metal oxide also for the application. But not just this one. First topic we talk about is chemical synthesis. It is chemical deposition. Also use its chemical functionalization or upstream beacons by its chemical process. Or it's very good or recently studied. Yeah. For example, graphene oxide transport to reduced form. It is chemical reduced form graphene. We just a simple scan. That graphite oxide to reduce form. It is chemical reduced form graphite oxide. So this is a very simple cyclopolarimetry, but we can deposition a graphite oxide on a reduced form graphite oxide on electrode surface. This also reduced form combine RGO and porphyrin, gold porphyrin compound, 2D and 2D. Yeah. Also, we can calculate the amount deposition on the electrode surface by EQCM, its chemical deposition. We just measure the mass by the EQCM deposition. Also can perform its polymerization, not just its electrode deposition. But whole energy application, we also study about argent reduction reaction, ORR reaction. Use the graphite oxide, reduced from graphite oxide, with some compound or some nanomaterial. This ORR case. But not just ORR case for energy. We also use for biosensor. For example, Parasol compound detection. Yeah. This also one way is for the argent reduction. One way is for the Parasol detection. So sensing and energy storage device both is our nanomaterial application. But not just this one. 2007, we begin first water oxidation. It's very famous for energy field now. Also detection for the coronavirus, the base, DNA or RNA base, adenine or guanine. But we begin the 2007 2007, we have begin energy field study. We also study about the virus study. So it's also very good. Still now, it's very good. Also use RDE to detection the intermediate. For example, hydrogen peroxide. Yeah. So this just talk about ORR, OER. We have studied use the different type or the different nanomaterial, but not just this one. We also use nanomaterial for the food analysis or the clinical analysis. For example, the oxygen guanine now also important for the DNA RNA base, the damage detection. One way is also food safety detection. For example, rectoamine, yeah, is very also important for the food analysis. This detection, one organic analysis, one for the food analysis. Okay, so many 2D material combined with 2D or some nanocomposite. We will use different type application. This nitro compound also famous. Yeah, but not just this one. We was detection different drug. Use a different type for a different drug. Yeah, anti-cancer or the other drug detection, or also for the environmental detection. So this 2D compound and 2D compound, composite compound, we will load food analysis or the clinical analysis. Also binary nanosheet application. Okay, and this also application for the DNA or RNA damage biomark detection, detection of biomark damage. Yeah, but so many detection depollution. One, this example, the PEDOT. It's very famous for solar cell or dye-sensitive solar cell contact compound depollution by electrochemical depollution. Also, some component application for the DSSC. Also, depollution of binary PTAU hybrid film nanoparticle. This is just chemical depollution. Or we can measure the amount by the EQCM or more. This is just a detection how amount of the frequency change, but we can understand which one got depollution potential range, or which one PT potential range, or about not just photometry, also the amount of depollution. It's nanogram degree, nanogram level depollution amount we can measure. So it's just a PT or AU. We understand we can look the particle size or any more information. We also use different type nanomaterial for the ascorbic acid, dopamine, or uric acid simultaneous detection. Don't need separation. So this is also very famous field for the dopamine or neurotransmitter determination by the modified electron. These are three analyte. We can just one scan detection ascorbic acid, dopamine, and uric acid. Don't need separation. Yeah, but so many important is chemical sensor or biosensor we are interested. For example, glucose, insulin, or body fat or more. We also hope combine with the smartphone for the some data transfer easy or more or far distance detection. So nano approach for biosensor is very important, or glucose sensor or more, or cholesterol or anything field detection. Yeah, but we have one case. It's enzyme case biosensor. Enzyme case is very important. It's high specific. We need an enzyme, but the enzyme electron transport between electron surface and the enzyme is high technique. The mean direct is chemistry. I will also talk. So how to electron transport between the big molecule to the electron surface, or one cell the electron can transport to the electron surface also important. So this is important because the hemoglobin or the enzyme is big molecule, but the active center only here. We must get electron or give electron from the active center ion. So this how the interaction with electron surface is very important. But not just this one. So many samples we can get for analyte. For example, from blood, urine, or saliva, or water, or lab sample, or environment. So many elements we can use for our modified electrode. Yeah, also this just scheme show how biosensor application, including the sample, including the material, including the signal transport. But so many biomaterial also application, DNA, RNA, antigen, or antibody, or enzyme, or cell also used for this field. So the important of the third generation glucose sensor, why or what is the third generation? The important is enzyme. So I will show this scheme glucose biosensor in general with detecting glucose or oxygen or hydrogen peroxide. But the different generation is related to this field. First generation just detection hydrogen peroxide. Second generation is electron transport between enzyme and the medium. Third generation is direct chemistry from the glucose and enzyme and electron surface. So in our lab, we forecast the medium, second generation, or direct chemistry, third generation. So this third generation is very important for development. But in the market, generally just first generation or some second generation. Yeah, but in our lab, we forecast the third generation, use nanomaterial or semiconductor with N9. So this we use 2N9, glucose oxidase, and HRP. Maybe we call this is fourth generation, 2N9 system glucose direct. Okay, so many mechanisms we will study, including mediate or including no-mediate. Yeah, for the biosensor application. Yeah, this is also mediate case, but sometimes we don't need no mediate case. The rest is chemistry. The last though, I will just talk about the direct biochemistry. It's third generation or fourth generation. Glucose uses some nanomaterial, we can direct its chemistry response on the electrode surface. We have some publication biosensor electronic. For example, glucose oxidase use CNT and carbon nanotube. This one. The second, we also use CNT and platinum for the myoglobin direct its chemistry. We also use glucose biosensor with graphene. So both cases is direct its chemistry. It's third generation or fourth generation. This also detection hydrogen peroxide by catalysis. Catalysis is so famous in that. Also direct its chemistry. So this part is direct its chemistry. We will also talk some part for photocatalysis or photocatalysis application. We use different type molybdate, selenium for the photocatalysis for drug degradation. This one case for degradation, the drug degradation, the mean for photocatalysis. This just catalysis, this the mechanism. This is degradation procedure for the drug. We also use for the supercapacitor or energy storage device. So this case, we from nature biomass, get an active carbon and application for different field, sensor, energy storage, supercapacitor, or the other one. But here, we also use focus on the supercapacitor. This supercapacitor detection, yeah, this synthesis, active carbon, one-way detection sensor, one-way detection supercapacitor. So this use the active carbon or graphene sheet for the sensor and energy application from the natural biomass. This detection, LED detection method. This is my electrode and catalysis. These two electrodes and set up my catalysis by photometry or charge-discharge device. This is also detection by my supercapacitor. The last of field, I will talk hydrogen peroxide. It's very important for our human body. We have so many field study use nanomaterial. Or non-enzyme case or enzyme case. This one case for the hydrogen peroxide. But also biomimic compound produce hydrogen peroxide or free radical. This one application for the electrochatalysis. This response by the ESR. We also detection living cell in vivo or in vitro detection from cell stimulate hydrogen peroxide evolution and DNA detection. So this detection by different nanomaterial molecular compound detection the hydrogen peroxide in living cell. This is detection the signal. This also detection from living cell real-time hydrogen peroxide is very favorable for our health or or cancer target detection. Use mechanism and carbon oxide. We also detection so many important compound or drug nitrophenol by different nanomaterial. Nitrophenol, we can see the beautiful cyclophotometry, different compound, similar but the good separation. This photometry detection by DFV detection different nitro compound. The last part we will combine use one compound for 3-field application. We use cobalt multi-selenium, the catalysis. This also catalysis. But we application for supercapacitor. We also application for sensor. We also application for biofuel. This sensor mechanism. This sensor detection by DFV. This supercapacitor application by CV or by charge discharge device. We also application for biofuel. Ni case or non-ni case use different nanomaterial carbon material. The biofuel Ni case we have used different PT nanoparticle or Ni case or CNT or graphene. This glucose oxidation detection, the bioanode. This is oxygen reduction detection or ER detection, biosensor. So we hope can application for energy field. This set up in a lab for the biofuel cell. This is a mechanism scheme. So we use different nanomaterial for sensor, biosensor, biofuel cell, supercapacitor, also used for the semiconductor for the photocatalysis or the degradation for detection or more. This is biosensor by photocatalysis application. This application for photocatalysis or also sensing application. This is a mechanism for DPAH sensing application and degradation. This is a mechanism for chemical and electrochemical procedure. We have some field application. One is forecast nanomaterial. For example, different journal material A or ACS applied material interface, some application for nanomaterial. The second, we also application for biosensor or bioelectronic. So this application, the third is chemistry for biosensor, bioelectronic. We also forecast electrochemistry, use different type for electrochemistry application by the different type anti-cancer drug or another field or for food analysis or also the clinical medicine sensing application.